Hi, my name's Timothy, and I'm a member of Ontario Tech University's FSAE racing team. I'd like to guide you through our accumulator. We start with the foundation of our accumulator, these 21700 batteries from Samsung. We have tabs welded onto the bottom and the top, with 4 weld points on each. We then place those batteries into the frame. These frames have O-rings seated in them with dielectric grease to help seal out any water. Then the tabs are placed through these openings on the PCB, folded over and bolted together. PCB routes the power through the fuses to the JST connectors. The wires from the JST connectors run through the PCB, through the entire battery to the other side where we have our battery management system. These frames help to guide the air through the battery and cool it as the car moves. The air enters in the front, goes over the batteries, and out here at the back. Finally, we have these clear plastic protectors on top so that we can see inside the battery at all times.
Shown here is the connection between the cells in various stages of assembly. We have one cell here and another cell here. Each of these is a parallel element of 4 cells. We would take the tabs and then bend them over like such. Through that, a bolt would go through with the positive locking mechanism seen on top here, where bent metal prevents the bolt from rotating. Over here, the thermistors can be seen. The thermistor wire would then be placed right on top of the cell terminal for the most accurate temperature reading. As mentioned, this is the connector for the thermistor to go to the cell. Then traces take it from this connector over to the set of headers over here, which then connect to the BMS. Here you can see the nickel strip joining 2 parallel elements of cells. A trace emanates from that to a fuse, SMD fuse on the board, and then that continues towards the BMS because that is the V-Sense line, and it's present for each of the parallel elements in the entire module.
This is a completed module, so you can see the side panel is now attached, and between the modules for insulation and fire protection we have a sheet of FR4, then aluminum and FR4 on the other side. This sheet would be assembled like so against the module, having bolt points going into the bottom of the accumulator. On the back of the module here you can see the mains plugs, positive and negative. This allows for the connection of multiple modules together to power the vehicle. I'm holding here the female end of the connector. This is internal to the module. You can see the keying on the rim as cutouts on the left and the right sides, and then you can see the matching keying on the male version of the connector, again left and right sides. These two would be connected like so. The click means that the connection has occurred successfully, and then to remove the connection you press the button in on the side and then through a little bit of effort separate the two.
In this case, the bus bar joining the parallel elements of the cells is not shown. This is just to illustrate how the bus bars connecting the lower half of the module to the upper half of the module is located, as well as the 2 bus bars which connect the module to the maintenance plugs.
This is the DC-DC converter board. On this side of the board, along with this section of the board, you can see the LV, and on this section of the board you can see HV. This is a DC-DC converter which is rated for 400 volts. The signal to the DC-DC converter passes through these 2 optocouplers. The LV and HV parts of the board are separated by these 2 lines 16.76 millimeters apart, and these 2 lines 6.3 millimeters apart.